Hi everyone and welcome to Chem class. Today we are going to look at the ways that we can determine the calibration factor for a calorimeter. It doesn't matter which way we do the calibration, we're still going to be calculating the calibration factor by taking the amount of energy that's put into the calorimeter and divided by the temperature increase or decrease, so the difference in temperature. The calibration factor can be determined using either chemical calibration or electrical calibration. In both instances, we're putting a known amount of energy into the calorimeter. Either it's a known amount of chemical energy or a known amount of electrical energy. And then we just observe how the temperature changes. Let's work through an example of a chemical calibration. An example could be that you have a known mass, let's say, of a fuel that we know we've got data for. So this is why it's a known amount of chemical energy. We know how much energy we get from a gram or a mole of butane. It's something you can get from your data book. Let's just make up the rest of this hypothetical situation. And the temperature has to change. Let's say it rises by 2.5 degrees Celsius. Okay, so if we're going to calculate the calibration factor, the known amount of chemical energy, I look at the data book and I see that butane can release 49.7 kilojoules of energy for every gram. I've got 2.85 grams, so that means that the known amount of energy, so my calibration factor is the known amount of energy, I would be taking the 2.85 grams that I have of butane multiplied by how much energy I get from every gram. I have to divide by the temperature change, which in this case is 2.5. I put that all into the calculator and I get 56.7. This was in kilojoules, so that means that my calibration factor is in kilojoules per degree Celsius. So a known amount of chemical energy can help us to get the calibration factor. Let's have a look at electrical calibration. Our known amount of energy can come from having a known amount of volts, amps, and known amount of time. So let's have a look at an example. 6.0 volts of, let's just look up a situation, is okay. Let's say that the temperature rises the same. Okay, so the calibration factor, we still need to get the known amount of energy, but we are going to use this particular formula, E equals VIT. So for E equals VIT, remember this as VAS, volts, amps, seconds, just to tell you the units that you're using. So the amounts of energy that's gone in, because calibration factor is amounts of energy, we have 6.0 volts, 1.5 amps, and the time, be careful, it has to be in seconds. It says 1 hour, that would be 60 by 60, because we're putting that into seconds, all over my temperature change, which was again 2.5. Put that all into the calculator. Okay, we get 12960. Now all we need to know in this instance is that the energy calculated this way will always come out in joules. You could turn this into kilojoules by dividing it by 1,000 if you like, by degrees Celsius. So, two ways to calibrate our calorimeter, chemical or electrical. Both instances you need to know the amount of energy that has been inputted so that you can divide it by the difference in temperature. If it's electrical calibration, you do need to remember this added formula in order to get the energy content of that electrical calibration. Hope this helps.